Aadarsh here, representing the web team at DSE VIT Bhopal. This is the first video of the ongoing playlist about system architecture and design. So in this playlist, we'll be discussing about the fundamentals of system architecture. We'll be discussing all the concepts that come under system architecture and design. We'll be discussing the different techniques involved in building a large-scale applications. We'll be also discussing it, like we'll be also building demo applications, like we'll be cloning WhatsApp, cloning Instagram, like how the system architecture works for WhatsApp, and then we'll be discussing that in this ongoing playlist. We'll first get started with knowing what are the different tiers involved in a software application. What are the different tiers? So we have four different types of tiers, which is a single tier, two tier architecture, three tier architecture, and entire architecture. So let's get started. We'll get started with what a tier actually is. So what is a tier? You can think a tier as a logical separation of components in a software application. It is a logical separation of components. By components, what I mean is there are different components when it comes to a software application. There is database, there is UI UX, we have caching component, we have a messaging queue, and etc. So basically there are different, like we build a whole tier by combining all these components together. So a tier is basically a separation of all these components together. For example, let's say this is our user client, UI UX is our user client. We have our backend server here. This is our database. We could have a messaging queue here. So these are logical separation of these components. Like you can see all these components, and we're just logically separating them in order for them to work combined together. So this is what a tier actually means. So now we'll be discussing the different types of tier. There is one tier architecture, one tier. There is two tier, then three tier architecture, and there is entire architecture. So these are the four different types of architecture. We'll be discussing all of them briefly one on one. So yeah, let's get started with it. So now let's discuss about single tier architecture, also known as one tier architecture. So what a single tier architecture is, it is a system where the user interface, the backend business logic, as well as the database all lies inside one single system. Like let's say we'll take this, let's say this is our laptop, and we have a client code, basically UI UX, the thing you can see like front end. This is what we call client, your backend server, your database, all lie in a single system. Like let's say the system is your laptop, all the three services lie inside your laptop itself. There is no need for any other external servers to make calls, or any external database to make calls and to fulfill a particular requirement. So the best example for single tier architecture would be desktop applications. Desktop application, for example, let's say MS Excel. MS Excel, you can take your PC, normal PC games, like Call of Duty or something. You can also take Photoshop. So like these are all the basic examples of single tier architecture. Like all these lie under desktop application. So yeah, desktop application. All these are examples of desktop applications. So there is no need for this particular application. Like there is no need for Microsoft Excel to make any external database calls to any other server. Like everything happens inside your laptop itself. Like also when you play when you play normal PC games, when you download that game, all the game code files have come to your system. So there is no need for any external database calls or any external server calls for this. So the greatest advantage of single tier architecture is there is no latency whatsoever, because as I said many times, there is no external service out there to make any database calls. So everything lies in your system itself. So there is no network latency. you do not need to store your data elsewhere. Like there is no third-party database service in order for you to store your data. So if you're playing any games, so like let's say you finish a mission or something, so that particular mission's data will be stored in your system itself. It does not have to store it in any other third-party services. So everything happens in your system and everything is stored in your system. So these are the advantages. There is no network latency. That is, you don't have to make any calls to your database in order to save your data. Everything lies in this particular system. So the disadvantages of this particular architecture is that like once the code is shipped and it is in your system, the owner of that particular software or platform cannot make any changes whatsoever. He could push updates onto the platform, but it's all up to you if you want to download that update, if you want to take that update or something. Like let's say Microsoft Excel's release a new version of itself, but it's now relies on you if you really want to update this, or you want to switch back to the old version, if you want to stick to the old version. So that's one thing. This is one example where in let's say 10 to 20 years back, when game developers used to ship off a game, and once it comes to production, once people download that game, then some of the developers come through a particular bug in the code where user cannot move or something. There is this one little glitch in the code. Now nothing could be done because once the game is shipped, they cannot send you updates or something. So once the game is shipped, everything is like the studio guys cannot make any changes to it. So this is one disadvantage. This is 20-30 years back. This is one example. So this is single tier architecture. Now next we will be discussing about two tier architecture. Two tier architecture involves two major components. One is the client and one is the server. Client is responsible for the user interface and the business logic of the platform, and the server is responsible for running the database and to store the data in the particular database. That's why the server is responsible here. So now let's say one great example for this would be a to-do list application. Now let's say we are building a to-do list application. So how we will proceed on with this is we'll be having a client. Let's say it's a mobile client or a desktop client, does not matter. This is basically a client which handles a user interface, and business logic. So both of these components are inside our client, and our backend server is only responsible for running the database, basically storing all the information that client sends into the database. So how does the exchange of data takes place here is we use this request response model where the client sends the server a request, and in turn will send the client again a response for that particular request. Okay, now let's say we are adding an item to our to-do list. So let's say I need to buy groceries today, so I add that to our to-do list. So our business logic will, like let's say I click the plus button, so the plus button will all be written in our business logic. So let's say when I press a add button to add a new item into the to-do list, our business logic will run accordingly and add that item to the to-do list. Now in order for me to persist that item into the data, like let's say after reloading I don't want the item to go, I need the item to be there one after also I quit the application and come back. So how will that be? So that will take place on a database. So let's say I add this item where I remind myself to buy groceries for tomorrow. So once that is done, our business logic will then send a request to our server saying that you need to add this to the database because we need to remind him about this. So the request will contain certain headers and the data would be need to buy groceries, that will be containing JSON data. We'll discuss more about this in the coming videos, but yeah, we'll be sending him a request saying that you need to store this into your particular database, and in turn we'll be sending the response. The response could be anything. You could send him data successfully stored. You can send him this particular data as a response. So the client will know, okay, so the data is stored, and he could display it. When we could also make a UI change where we'll be displaying that data is stored. So this is how a client So this is how a two-tier architecture works. There are two major components involved. One is the client and one is the server. So now we'll be discussing more about three-tier architecture, where there will be a middle layer between this. We'll basically be splitting a backend server and a database separately in three-tier architecture. Which we'll be discussing next. So three-tier architecture. In three-tier architecture, we have three different components. One is the client, which is responsible for the user interface of the particular application. One is the backend server, which will hold all the business logic required for the particular application. One is the database to store all the data of the application. Unlike two-tier architecture, where we had two different components, one was client, one was server. In three-tier architecture, we just split the server into two different types. One is the backend server with the business logic in it, and one was the database. So we just split the two-tier architecture server into two different categories here. And in the two-tier architecture, the client used to have UI UX as well as business logic in it. But now in three-tier architecture, the client only has the UI UX. It does not contain any business logic in it whatsoever. So all the business logic lies on the backend server. So let's take an example where we are building a blog application where people could come and post their blogs there. So how will we get started is our client will host all the necessary HTML and CSS to display our blog site, where we can go and navigate through all different blogs. We can post new blogs, we can delete new blogs, etc., etc. So let's say I log on to the platform and I need to post a new blog. I write all my blog and I just need to post it now. So what I will be doing is I will be sending a request. As we discussed in the last concept, to the organization, we will be sending a request to our backend server. Okay, and what that request will be is I am posting my new blog. So we are basically creating a new instance. So let's say we have this. I have just divided our backend server contains four different business logic. We could create new blogs, we could delete a blog, we could update a blog, and we could read a particular blog. So this is a business logic in our backend server, for example. So now let's say I need to create a new blog. So I'm sending a request to basically post a new blog. So our business logic will have this particular line of code where we'll be accepting requests from the client to create a new blog and persisting on that blog to the database. We'll be storing the data of the blog. So we'll be having different paras and all that, the title, who created the blog, we'll be having all those data. So once the client sends us all the data to our data backend server, our business logic will run accordingly and save the data onto the database. So database will have different, like let's say we are using a SQL database here. So we'll be having the blog ID here, the blog title, the blog text, what is the actual content of the blog, who was the blog written by, the date the particular blog was posted. So we will be sending on this data to our database to be stored here. So once this is stored here, we'll be sending back a response back to the client saying, okay, your data is stored in the database. So okay, this is done now. Let's say the particular user wants to update his blog. Let's say there was one spelling mistake there and he wants to update it. So again, what he will be doing is sending a update request to a backend server. And update request, what the update request will be like, we'll be sending that, but we'll be having this blog IDs here. So while sending a request, he'll be sending us a blog ID. Let's say I want to update this particular blog, so he'll be sending that, and once he hits that updates business logic here, what we'll be doing, like let's say he wants to update his blog with the ID 1. So we'll be querying our database for the ID 1. So we find ID 1, he wants to update his title. So he'll be updating the title from XYZ to ABC. So once that is done, we update his query and send back the response saying that okay, your title was updated. So this is how this works, and the same for delete and same for read. Now let's say he wants to delete that particular blog. So what he'll be doing is sending us a delete response with a particular blog ID. Let's say he wants to delete his blog with the ID 1. So he'll be sending a request with the ID in it. So we'll be running our business logic accordingly to delete that particular blog. So we'll be calling our database, saying our database to delete the blog with the ID of 1. So what our database will be doing is basically deleting the blog with the ID number 1. The same as well as for read. Now let's say he wants to read the blog he posted. So he'll be sending a request saying I want to read the blog with ID 1. So we'll be sending back, we'll be searching for ID 1. Now let's say ID 1 is not there. Now let's say he creates a new blog with ID number 2 and with all the appropriate data in it. So he wants to read that particular, he wants to read his block number 2. So what he'll be doing is sending a response saying, I want to read my particular block, can you show me my block? So we'll be querying a database for block number 2 and we'll be sending the data back to the client here. So where he will be able to read. So this is how a 3-tier architecture works. So next we'll be discussing about n-tier architecture. N-tier architecture. So next we'll be discussing about n-tier architecture. This was 3-tier architecture. N-tier application. N-tier application basically application which has 3 or more components involved in it. Previously we saw 3 different types of components. Those were client, server, and database. Now let's say an application with more than these 3 components are known as comes under what do you call it, entire application. Entire application, like let's say we have a caching component, a load balancer component, a message queue component, a component which involves processing of huge amount of data. Let's say Netflix. Let's take Netflix as an example. Netflix basically deals with thousands of gigabytes of data every day, which Netflix needs to stream from its server to our device. It needs to stream video data every second. It involves a particular component which involves processing of huge data. A particular component which only runs for search queries. Let's say we search something and we need to query our database which has a lot of data in it. So we need it to be quick. So we create a separate component to handle a search for it, search related task. So this is all comes under entire application. We'll be learning all these concepts separately in the upcoming videos. Companies like Facebook, Instagram, Uber all work with entire architecture because there is a lot of subcategories involved in this whole application, and it cannot be built on single tier architecture, 2-tier architecture, or 3-tier architecture, because these are complex applications and they need more than just 3 different components running. Entire applications are like all these components are built separately, so which makes it easy to build. Because let's say we are working in a team and we basically split our team into small groups and we assign them particular tasks. Let's say a team is responsible for building cache servers, a team is responsible for building constructing load balancers, a team is responsible for message queues and all that. We basically separate our teams and they work according to their particular domain. So this makes management easier as every single one is working on their own component and there is no interference between it. So for example, let's say someone is working on message queues and there is one update in message queue, that there needs to be one update in message queue. So we need not need to stop our whole application just for this one particular update, because as I said, this works independently. Message queue is handled by a particular group of people which works totally independent of this whole application. Let's say our message queue is just down for 2 minutes and we update our message queue again and it is again back into our application. So none of these services stop in our application. Everything keeps running as it is, all independent. So this is entire architecture. So these are the different tiers involved in software architecture. If you have any doubts regarding this topic, let us know in the comments section. We'll reply as soon as possible. If you need to contact us, you'll find all the necessary links are down in the description. So make sure to check that out. So in the next video, we'll be learning about HTTP push, HTTP pull, client-side rendering, server-side rendering, RESTful APIs, and all. So stay tuned. Cheers. Thank you.